Hello everyone, I'm going to be doing the 2016 AP Physics C Mechanics FRQ question 1. So let's get started. So car mass M, blah blah blah, force attached, okay, to the right, motion sense, acceleration positive, fraction. Okay, so as we know, the direction of the motion is toward the right and there is friction, so we can tell that there is force of friction to the left because force of friction is always opposite to the direction of motion, and since we know it's actually moving towards the right, that means the force tension from the string must be bigger than the force of friction, and obviously it is not moving vertically, so that means force normal and mg must be the same. And that would be it for part A. So this one I already did before. It was just plotting the points given. So as we know, the equation force equals ma is already a linearized equation, so you don't actually have to do any linearization to get a straight line from the graph. So once you do the straight line, make sure you always use a ruler, otherwise you won't get the point. We need to calculate the mass of the cart. So how are we going to calculate the mass of the cart? So I took 2 points with the teal line, so this will be roughly 0.55 at 0.6 and 0.3 at around 0.04. So we just have to calculate this. So the slope is equal to, make sure you define that what you're calculating is the slope. So we're going to just do rise over run, 0.6 minus 0.04 divided by 0.55 minus 0.3. And this will be roughly equal to, let me plug this into the calculator. And that would be roughly equal to 2.24. So once you get that, we're going to go back to the F equals ma equation. So if you notice, let me write out this equation, y equals mx. The force is normally on the y-axis. However, this time it's on the x-axis, and the acceleration is on the y-axis, but normally it's on the x-axis. So what does this mean? Well, this graph represents this equation rewritten. So to make it, we'll have to do A is equal to force divided by m. So that way, it looks more like this. And this matches because the force is on the x-axis and the A is on the y-axis, which means that the slope is going to be equal to 1 over m. So a couple mistakes people would make is they don't realize this connection between the F equals ma linear equation and the axis of the graph. So now we know that the slope is going to be equal to 1 over m. And the slope we got was 2.24. So we're going to do 2.24 equals 1 over m. So that's really just 1 over 1 over 2.24, which is roughly equal to 0.446, which is roughly close to the actual answer. That should get you the point. And don't forget your units. I almost forgot the units there, which is kg. Okay, so they're asking, using the straight line from the graph, determine the magnitude of the force of friction. So we know that when the force of friction, there's going to be no acceleration, which means we just have to look where acceleration is equal to 0, also known as the x-intercept, which is roughly around here, which is, we'll call it about 0.27. So the x-intercept, which is equal to around 0.27. So, and that would be 0.27 newtons. And that would be your answer for B, I. Okay. And now we have to determine the acceleration of the cart. So we just have to use the F net equals ma equation again. So we're going to do F net, which is equal to ma. And we're going to rearrange this equation. So solving for acceleration, which would be F net divided by mass. And now what is F net? F net would be force applied minus the force of friction, which is given here 0.45 and 0.27, which we solved for earlier, which would be 0.45 minus 0.27, which is 0.18 newtons. So now we have both the mass and the newtons, which would roughly equal 0.18 divided by 0.04, let's just call this 45, just round up. 0.18 and 0.45, which would be roughly equal to 0.4 meters per second squared. And that would be our answer for the acceleration. So now I'm going to make some room here. The string breaks at time t equals 2.0. Calculate the time it takes for the string to stop after the string breaks. Okay. So they tell us t equals 0 time. Okay. So all we have to do is use the kinematics equation. So we're going to use v final equals v initial plus at. And we just have to solve for v final, and we know that the v initial is going to be 0 because the object starts from rest, so this goes to 0, and we have the acceleration that we just solved for, which is 0.4, so that would be 0.4 times 2 seconds, which is just 0.8 meters per second. And now they're asking for calculate the time. Okay, so now we'll just have to reuse the same equation, v final equals v initial t plus 1/2. Sorry, wrong equation. Oh shoot, I was thinking about a different equation, my bad. That's 0. V initial plus at. So we are solving for the time, right? So it says when the cart stops, right? So that means this v final is actually equal to 0, and this new v initial is actually our old v final. So we can do 0 equals 0.8, and this is going to be, what is a actually in this equation? Well, A is going to be equal to force net equals, or actually just force equals to ma, and A is equal to force over m. And force in this situation is actually going to be the force of friction. And we know the force of friction is going to be negative in this situation. So if we do negative force of friction divided by mass, and now we're solving for time, we're going just to have to add force of friction divided by mass, t equals 0.8. So we're going to multiply mass over and divide force of friction, so it'll be 0.8 times the mass divided by force of friction. And remember, the force of friction is our y-intercept right here, which was 0.27. So we're going to do 0.27 times 0.8, and our mass was 0.45. And this is roughly equal to 0.8 times 0.45, 0.27, and this is equal to around 1.29 seconds. That will be our answer for that. And now they're asking, will the slope of your new line be greater than less than blah, 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 blah. So the thing to note is that it's the same mass but greater force of friction. So as we know, if the slope is equal to 1 over m, and if the mass is the same, then that means the slope's going to be the same. So that means this is going to be equal to, however, well, they say it is a greater force of friction, and as we know, the force of friction is equal to the x-intercept. So if the force of friction is greater than, then this will also have to be greater than. And that concludes.